Hola, I am Arunava, and this is the Boost Start Python video. And in this video, what I'm going to do is I'm going to walk you down through all the basic syntaxes and through all the basic commands that you need to get started with Python in absolutely no time. So I'm just gonna assume that you have some basic programming knowledge. Okay, so for those of you who don't have Python installed on your system, here's what you're gonna do. Now, if you're on Linux, then you can you can start up your terminal, and there you are with your terminal, and you can say Python 3, and you are in your Python interpreter. If you're in Windows or Mac, what you're gonna do is you're gonna go in Google and type Python, and the first link that comes up is what you need. You go head to the first link and go to the download section and go for Python 3.6.4. Okay, that's what you're gonna practice in this video, Python 3.6.4. Okay, so as you can see, the download has started, and depending on your system, it will download the compatible file. If you're in Windows, it will download an exe. If you're in Mac, I guess it's .dmg. Yeah, that's it. Let's go get started with Python with some hands-on coding. Alright, let's start coding. Now, first, you're gonna pop up in your interpreter or your IDE, whatever you're comfortable with, and then you can follow me. So here I am on my interpreter, or actually I'm in my terminal, and I'm just gonna type Python 3, and I'm into my Python interpreter, and I'm gonna show you everything inside this terminal. Alright, so on to the first command, the print command. Okay, so let's do some hello world programming. Alright, so print, and then you go hello and world. So there you go. That's a simple print statement, the basic print statement. That's all you need to print a statement. Now that's about printing strings. Then if you want to print numbers, all you want to do is change this to numbers. 34. Let's print 34. Good. All right, and characters, right, or even floats, right? All right, so there is your basic print. Okay, let's now print multiple arguments or pass multiple arguments at a time with the print statement and print all of them at once. Okay, let's see. So print, let's say hello, and you're gonna end your single colon there, and let's say some number. All right, let's say 7.45. Let's say a character. What else? Let's say a boolean value, TRU. So there you go. Okay, so everything is printed. Now let's note the symmetry here. Every one of the arguments is printed with a space between them. Okay, now this we can change. We can change how all the arguments that are passed into print statement are separated. So by default, it is sep space like this. So that is the output. If sep is equals to a space, then this is how it's printed, and sep is equals to space is by default. Now if you say that sep is something else, let's see. Okay, sep is not a space, it's blank, then everything is printed without this space. All the arguments that are passed to the print statement are printed without any spaces. Okay, now similarly, you can pass anything to that separator, and that will be used to separate all of the arguments that are passed to the print statement. Okay, so let's see an example. All right, so let's say space and separator and space. So if I use this, so there you go, a space, let me show you, a space followed by the separator word, and then a space is there between every one of the arguments that is passed to this print function, right? All right, now let's notice something else that's happening here. There is a new line that's appended at the end, which we're not able to see, right? So there's a new line parameter over there. Let's see. Okay, so that's our separator, and let's get rid of that for now. Okay, now let's see about the end argument. Okay, end is a new line. That's a escape character for mentioning that that's a new line. Okay, so there you go. Everything is normal. Now what happens if I remove this end? I pass a blank to this end argument. There we go, no new line. My interpreter starts after what gets printed. So now you can fire up your imagination and pass in anything that you want for your print statement to end with. So let's do that. Okay, this is exciting. Now, so what do we pass to end with? Let's see. Let's say QWERTY. Off the top of my head, I don't know where did that came from. Anyway, so QWERTY. So there you go. Your statement ends with a QWERTY and a new line after it. So how cool is that? Alright, one thing that you should notice here, that this is the end is equals to blank a new line by default, right? So if you omit this whole end argument thing, then there you go. So you understand that end has by default a new line parameter passed to it. Let's now see how to pass multiple lines to the print statement. Alright, print, and you're gonna say 3 quotes, and then you can write your sentence. So there I am recording, and you can have enters here, recording my first video. Let's see how it goes. And when you're done with all the multiple lines, then you're gonna end your 3 quotes and the function, and there you go, everything gets printed. Now you notice that there's a new line printed over here, right? So where does this new line comes from? So we have a new line over here already, and since the default value that is passed to the end argument is also a new line, so a completely new line gets appended. Alright, let's now look at a few escape characters that are available. Now one of the escape characters that you already saw is the new line. So this is an escape character which says that you have to print a new line. Let's go ahead and see some examples. So hello, and if you say /n, this means that a new line will be appended, as you all already saw. So there you go, a new line appended and an extra new line because of the default value passed to the end. Okay, now let's say a /t, a \t followed by word. Now what is \t? A \t says that there should be a tab there. So a tab, that is a space, not a space exactly, but a tab, like 4 spaces, is present in between hello and world. Now let's look at the most commonly used escape character, which is the / character, as you already saw. Now what's the / character is used is to escape characters. Well, there you go, recursive definition, I guess. Well, let's see what that means. Now if you say print and then you say let's say hello, and then you want to print single quotes, but you started your sentence with a single quote. So if you see there, if you have a single quote right over there, Python will think that your sentence has already ended and you cannot type anything more. So what do you need? Yes, you guessed it right, a / character to escape the incoming single quote, and then you can have everything else that you need. So there you go, a space followed by word, I guess, and then you can have your normal single quote that specifies the end of that sentence, and there you go, your single quote printed. There are lots of more escape characters available. I'll put a link in the description below so you can check them all out. Alright? Now let's move to some interesting arithmetic operations that are available in Python 3. Okay. So I'm gonna clean up this screen and let's get started by default with the, well, not by default, with the plus operator. So 2 + 3, 5. There you go, a simple addition. 2 - 3 - 1, a simple subtraction. 2 by 3, 0.6666666. A simple division. Now this is a float division, so all the decimal points are printed. Now if you want to do an integer division, all you need to do is say 2/3, and there you go, an integer division with all the decimal points ignored. Now let's do a multiplication. So 6 into 4, there you go, 24. What else? The modulo operator. Now what the modulo operator does is it returns the remainder. So if you divide 12 by 3, and what's the remainder? The remainder is 0. So that's what the modulo returns. So if you divide 13 by 3, well, you can obviously guess. Since 12 is 0, 13 will be 1. So there you go. The modulo operator returns the remainder. Okay, so that's all of the handy arithmetic operators that you would be requiring. Now, moving on to comparison operators. Now, what comparison operators are is basically they're used to compare two numbers or strings or floating values. Okay, so let's get some examples of how comparison operator works. So first, I'm going to start with the less than comparison operator. So 2 less than 3. Well, that's true, right? 3 less than 2. Well, that's false. That's not true. Okay, so moving on to these are simple, right? So moving on to the greater than comparison operator. So 3 is greater than 2. Well, yeah, that's true, obviously. And 3 is greater than 1. Oh, that's true. 3 is greater than 4. Well, what's crazy, man? Okay, so moving on to the less than equals to operator. So 3 less than equals to 3. Yeah, that's true. 3 less than equals to 4. That's true even. Moving on to the greater than equal to operator. So 4 greater than equals to 4. Yeah, since there is a equal to sign over there, so you can see what's happening there. So 4 greater than equals to 5. No, that's false, my friend. That's false. What are you doing? Okay. So there you have your basic comparison operators. And let's now see how to add comments to your code. Now, when you want to add comments to your code, all you want to do is start the statement by a hash, sharp, or octothorpe and follow whatever comment you need to add. So let's add some comment. This is a Pi3 boost tutorial. You're wrong in the spelling of tutorial, my friend. And there you go. Your comment is added. Okay, now moving on to variables. What are variables? So variables are like labels attached to your data temporarily. So you can have something like a equals to 5. So 5 is now stored in the variable a. So whenever you say a, 5 gets printed. So 5 contains or stores a. Now, similarly, you can have a string or a float or a boolean stored inside a variable. So let's see, a equals to the string. This is a Pi3 tutorial. So now a gets reassigned to the string. There you go. Now, there are a few naming conventions that you need to obey while naming your variables. You cannot start with a number. So you cannot say 2we is equals to 4. That's wrong. See, Python gets angry over there saying it's a syntax error. That's an exception which is thrown. We will learn about that later on. Okay, on to the next naming conventions. You only can have numbers 0 to 9 and small a to small z and capital A to capital Z in a variable, while following the fact that your variable name cannot start with a number, right? So you can have qw2 equals to 6. So that's valid. Python doesn't get angry over there. And as I said, you can have A to Z or capital A to capital Z and 0 to 9. So you cannot have symbols in your variable. So you cannot say A at is equals to 4. So there you go, Python gets angry again. So you cannot have symbols in your variable name. And also you cannot have spaces. So you cannot say a space q, a space q equals to 3. So that doesn't make sense, as you can see, right? Okay, now I already talked about this before, but let me just bring this into light. Okay, so we are now going to talk about the built-in data types that are available in Python. So let's get started. So the first data type that is built in Python and that you're going to talk about is the integer data type. So what is the integer data type? 3 is an integer. That's an integer data type. Next is the float data type. So 3.45, that's a float data type. Okay, what's a string? A string is a sentence in double quotes or a single quotes that has more than one character. So this is a string. This is a string. This is a string. Okay, a character is the one which has just one character inside it. Okay, and then we have boolean, that's true and false. This is boolean, right? Okay, and next we have none, right? So a equals none means that nothing is assigned to a. So that's a special data type actually. So you can see that a prints nothing. It's not containing 0 or a blank string. It's nothing. So if I have something like b equals to like a empty string, then a equals b is false. That's an important comparison operator that we missed before, an equals operator. So what that does is it checks the equality between the right hand side and the left hand side, and it returns true if both of them are equal. So there you have your none. And so assigning none to a variable signifies that the variable contains nothing or no value, right? Okay, let's now move on to some of the basic data structures that are available built into Python. So we're gonna start off with lists. So what are lists? Lists are data structures that stores multiple values of different data types or of the same data types, and you can access or perform operations on all these values stored in a list as and when required. So let's now see an example of how to declare lists. So let's say the variable name is a, and to declare a list you're gonna start with a square bracket and put all the values inside it one after the other, separated with commas. So let's start with 1, and then let's say 2, 3, 4. Let's have something from the string world and something from the character world, something from the float world, and then you gotta end your square bracket, and there you go, you have your first list. Now let's see how you can access these values that are stored inside the lists. To access values stored inside a list, you're gonna say a, that is the name of your lists, and then you're gonna start a square bracket, and then you're gonna put the number of the value that you require. So if you say 1, then it's gonna return 2. So the value stored at position 1 is 2. Now you have to realize something, that lists are 0 indexed. That means the numbering starts from 0. So 1 over here is 0, then 2 is 1, the position of 2 is 1, the position of 3 is 2, the position of 4 is 3, the position of Python is 4, the position of the rate is 5. I probably have lost count. So you can see that, right? So it's a 0 indexed. Now what will be a 1 indexed? 1 index will be the case where the numbering starts from 1. So if you want to access the first element that is stored inside a list, you're gonna say the name of the list followed by the position 0, and that's gonna give you the first element that is stored inside the list. Now let's have a quick look at negative indexes. So what are negative indexes? Well, negative indexes, when you say that the list followed by -1, what you're going to access is the last element over here. So -1 is going to give you the last element, that is the first element, if you want to say, from back. right? From backwards, the first element that is stored is what is gonna be printed when you say A with a position of -1. So as you can guess, with a -2, the second last element will be printed. Okay, so now you have a general idea of how to access elements that are stored inside list. Now let's see how you can change values that are stored inside list. So one thing you have to realize is that lists are immutable. That is, you can change the values that is stored inside the list when you initialized it. So you can say something like A0 and you are accessing the position 0 of the list A, and you can say that it is now pi. So if you now print the list, that you can see that the position 0, the element stored in position 0 is now changed to pi. Now let's go over some of the basic operations that you can perform on list, starting with append. So what is append? Append function is used when you want to add an item to the end of the list. So let's take an example. So say you have this list A and you want to append to it a new value. Append, say I don't know, let's say QWERTY, right? So now when you print the list, you can see that QWERTY is appended to the end of this list A. Now let's take a look at the insert function. So what the insert function does is you can insert elements at a specified index, right? So let's take an example. So here you have A, which has all these values, and let's say you want to insert at the position 4 a value of, I don't know, JU. Okay, so now when you print A, you can see at the position 4, here is 0, 1, 2, 3, and 4. At position 4, a value of JU is inserted. Moving on to the remove function. So what the remove function does is it removes the first occurrence of the past value inside the list. So let's take an example. Now here you can see that inside the list A, I have the values 2, 3, 4, JU, Python 4.6. So let's try it out. So A dot remove, and let's say we want to remove the value of 2, or let's say the value of 8. And if you now print the list, you can see the value of 8 is not present inside the list anymore. Now remember what I said, that it removes only the first occurrence of the value passed from the list. So let's take an example of that also. Let's say A, and let's insert inside it at position 3 a value of R, and then let's also append to this list a value of R. So if you want to print this list, there you have at position 3 a value of R, and at the end a value of R. Now let's see what happens when you use the remove command. So remove, and let's now print the list. So as you can see, it only removes the first occurrence of the letter R from the list. Not all the occurrences, but just the first occurrence. So also, if you now again remove R, well, there you should know, you get the logic right. So the last occurrence of R is also removed. Okay, let's now take a look at the pop function. So what the pop function does is it removes the item at the given position in the list and returns it. Okay, and if no index is specified, then the pop function removes and returns the last item in the list. Okay, so let's take an example. So here you have A, and let's say I want to call pop without any arguments. So A dot pop without any arguments. So as I said, it should remove the last element from the list and return it. So there you go, it returns the last element, and if you now see the list, so there is no QWERTY inside it. Now let's take an example of what happens when you pass an index inside pop. So here I have my list, and let's say I want to remove the JU character from the 4th position that I inserted. So if I say a dot pop, and if I pass in the index 4, it returns JU, and as you can already guess that JU is now removed from the list. Now let's take a look at the count function. So the name is quite intuitive. So as you can guess, the count function counts the number of values that are present inside the list. And what values? Well, the value that you pass to the count function. So my A has pi 2, 3, 4, Python, and 4.56. So if I say a dot count 4.56, it returns me a value of 1, since there is only one element inside the list with a value of 4.56. So as you saw, the count function returns the count of elements that is present inside the list. So let's take an example where the count function returns something more than 1. So, and here is my list A, and a dot count would return me a dot count for 2 would return me a value of 1, since there is just one element, which is 2, inside the list. If I now append to a value of 2, and if I now again count 2, well, there you go. You have 2 2's present inside the list, and so count would return a value of 2. Moving on to the sort function that is present with lists. So what the sort function does is, again, it's very intuitive, is it sorts the element that is present inside the list. So let's just try it out. So a dot sort, see, so there you have an error. Let's just see what this error is all about. So in my list, I have elements that are both string and integers. Now let's have a look at this error over here, type error. So type error says that less than sign is not supported between the instances of int and str. What that means is Python doesn't know that how to compare the values of the data types, that which one is int and another is str. Okay, so you cannot compare two values of one which is str and of one which is int. So you want to have a list where all the values are of the same data type, where Python can perform the comparisons smoothly. So let's have a list which says which has all the values from the same data type. So b equals 1. So let's just pick some random numbers: 34, 23, 12, 89, 0, 34, 56. And now if you call the sort function from the list for the list B, then all the numbers, all the values that are stored inside B should be sorted, and there you go, you have all your values sorted out. All right, on to the next function, which is reverse. And again, it's quite intuitive. The reverse function reverses all the values that are stored inside the lists. So let's take an example. A dot reverse would give me, well, actually we didn't saw what A had before, so let's just see what A has right now. So A starts with 2, 4.56, Python, 4, 3, 2, and pi. Now let's just call the reverse function one more time. And now as you can see that the arrangement of all the values that is stored inside A is now completely reversed. Now this is true for also the list that we created right now. So let's just take a look at the current condition of B, and let's now reverse it. Sorry. So there you go, B reversed. So the last function that we will be using for or on lists, right, which is the clear function. So, well, again, it's intuitive. what does a clear function does? A clear function would clear all the elements or all the values that are stored inside the list. So let's have a look at A right now. So this is the current condition of A, and let's call the clear function on it. Right now, there you go. All the values are removed from A. All right. I'm sorry that I said that it was the last function. Well, turns out that I missed one of the key functions, which is the len function. The len function gives you the number of elements or the number of values that are currently stored inside list. So let's see it in action. So I cleared out A. So let's use B. So if I use len on B, it gives me 8, which means that there are currently 8 values stored inside B. All right. So moving on to the next data structure that is available in Python, and these are called sets. They are very friendly. So what is the difference between sets and lists? Well, you can say all the operations that you perform currently on lists are almost all of them are available on sets. So what is the difference exactly? Inside lists, you can have multiple values which are the same. Inside sets, if you have taken Mathematics 101, then inside sets you cannot have two values more than once which are equal to each other. Okay, so let's get started. Let's see some examples. All right, let's declare some sets now. So the name of your set is A, and now instead of square brackets that you use for list, you're going to use curly braces to indicate that we are now using sets. And let's enter some values. So let's say Python 2.7, all right, 6, and let's say 45, let's say 78, let's say 90, let's say 12, let's say 3.456, and let's end the curly brace, and there you go, you have your first set. Now, as I said that you cannot have multiple values inside a set whose values are equal to each other. So let's see what happens if we do something like that. So let's say I am having 3.56. Well, you can see that Python takes it without throwing out any exceptions. But now, if I print out the list, well, you can see that there is only one 3.56. So you can have assurance that you can add multiple values which are equal without worrying about whether they are inside sets or not, and Python will take care of it. Now remember that you can always use your len function to see how many values are present inside a set. So len of A would give you 6, that there are currently 6 values present inside the set. Now, what are the most basic operations that comes to one's mind when we talk about sets? Like union, intersection, right? So all these basic operations are supported between two sets in Python. So let's just declare one more set and let's see how to perform those operations. All right, let's now start by declaring one more set which has some values. All right, so let's have B equals, and let's just print A for reference because I want to have something common between the two sets. So B equals 45, and then let's have 2.56, then let's have Python, then let's have 12, and let's have one more common between the two, 19. Okay, so there you go, you have your set B. Now let's see how to print the letters that are in A but not in B. That is, what I'm talking about is a subtraction operation, that a minus operation between the two sets. So if you say A minus B, there you go, the elements that are present inside A but not in B. Now moving on to how to print elements that are either in B or A. So we are doing an OR operation right now. So an OR operation on B. So there you go, all the values that are present inside both of them, so either in A or B. Okay, moving on to the operation which is the AND operation, which is the letters present in both A and B, which is the intersection operation, right? Present in both A and B. So there you go, the values that are present both in A and B. Now moving on to one more operation, which is the which prints out the letters in A or B but not in both. So for that you need the XOR symbol, and then there you go, so the letters present in A or B but not in both. Alright, let's now look at the add operation. So what does the add operation does is it adds element to the list. So let's watch it in action. So let's just redefine our list, our set, sorry. So Python 5.6 hash, something else 12, something more. Okay, there you go. So our set A is defined, and let's now watch add in action. So add, I'm gonna add at the rate to the set, and let's now print A, and there you go, at the rate is added to A. Okay, moving on to the remove operation. So what does remove operation does is it removes the mentioned element from the set. So let's watch it in action. So let's now remove the added at the rate to the set, and there you go, print the set, and there is no at the rate inside the set. Okay, let's now look at the pop operation. Now what the pop operation does is it removes the first element that is inside the list, set. So let's have a look at what the set currently contains. So let's print A. So the set A currently contains 5.6, a starting parenthesis, and a 12 and a hash. So the first element inside this set is 5.6. So as I defined pop, so if I call pop now, pop would remove the first element inside the set and would return that element. So pop, yeah, there you go, pop in action. Oh, that sounds nice actually, pop in action. Okay, Popeye. Anyway, so a.pop would remove the first element from the set. So let's now look at the set right now. So it contains the first, the starting parenthesis, and then the 12, and then a hash. So according to the definition, it should remove the first element, and there you go. It removes the parenthesis from the set and returns it. Moving on to the clear operation. So, well, you know what it does? It basically clears all the elements that are stored inside the set. So let's watch it in action. So A, there you go, 12 and hash is present, and if you now call clear on it, well, you can guess what's going to happen, that it's going to be an empty set. Okay, now let's move on to dictionaries. So dictionaries are one of the most useful data structures that are built into Python. So what are dictionaries? Dictionaries are basically an unordered set that stores key value pairs, and the keys that are stored inside a dictionary has to be unique. Alright, now let's look at a dictionary in action, how to create it and how to perform operations in it, and you will all get a better understanding of how it all works out. Okay, let's get started. So how do you create an empty dictionary? So let's say that let's say dictionary D1 equals to, and you start curly braces and end curly braces. Okay, so just like I said, right? So if I call type on this one, there you go, class dict, it is a dictionary. So if you are not aware of the type function, it basically returns you the type, the class the data type belongs to. Okay, so D1 is now a dict. So you just created yourself an empty dictionary. So let's just work on putting values inside this empty dictionary. Key value pairs. Okay, so D1, and inside the square brackets you mention the key that you want the value to have, and the key, say the key is key and the value is value. Okay, so D1, now when you print D1, D1 stores this key value pair in which this is the key and this is the value. Now, how do you query the value? Obviously, you're getting it. So to query the value, to query the value, you have to specify the key, and it returns your value. Okay. All right. Let's now initialize a dictionary with a few key value pairs already inside it. So D1 equals to 34, and let's say it has a key of something, I don't know. So then let's say it has something like a $, and it has a value of 90, and let's say a key of 12, and it has a value of TY, random stuff. So there you go. So your dictionary is created, and let's now print it and see how it's looking. So, well, it's looking good. So there you go, your dictionary created. Now, how do you query values out of it? Well, I already showed you. So to query values out of the dictionary, you have to specify the key, and it will return the specific value which the key stores. So that is a spelling mistake, I think, right? Oh, sorry, that was the value, right? Sorry. That was the value. So there you go. So you query the key, and it returns the value that the key stores. Now, let's now look at how to add new values to a dict. I already showed you how to add a new value to a dict, but I really didn't say that you were adding. So let me just show you one more. So, for D1, you specify the key. Let's say it's star, and then you give an equal sign and say what its value is. So this is a value, right? And there you go. Your key value pair is now added to the dictionary. Moving on to how do you delete a key value pair from a dictionary. So to delete a key value pair from a dictionary, all you have to do is to type the del command followed by the dictionary name and followed by the key inside the square parenthesis. So there you go. Key is not present. That's because we removed key. So let's just print D1, and let's see what are the values, key value pairs that are already stored, and let's now try that again. So D1 and 34, and if you hit enter, the key value pair 34POIU will be removed. So there you go. If you now print D1, there you go. The key value pair of 34 and POIU is now removed from the dictionary. Now let's see how can you see the size of the key value pairs that are stored inside a dict. So you already guessed it probably. So you can use the len function to see the number of key value pairs stored inside dictionary. So D1 has 3 key value pairs as printed by len, and there you can see that 1, 2, and a 3. So there you go, 3 key value pairs stored inside the dict. Okay, let's now move on to the update function that is present in the dict module. What the update function does is it basically allows you to add multiple key value pairs, and in the process, if you're adding or updating basically a key which is already present inside the dict, then it basically updates the value of that key. Okay, let's now watch it in action. So here we have the dict D1, which has this 3 key value pairs, and let's now update this dictionary with some new values. So if you have another dict, you can just specify that dict right over here. Let me just show you. Okay, so let's say we have another dict over here, and it's storing something like H is 7 and U is 0. Let's just stick with 2 values, and let's now update D1 with D2. So D1 now contains this extra new values right over here, extra new key value pairs right at the end. Now let's see what happens, as I said, if we are updating the dictionary with keys that are already present inside that dictionary. So let's just update DU to have something like, what do we have here, $, and let's just store a value of ampersand. So inside D1 we have $, storing a value of 90, and inside D2 we have $, storing a value of ampersand. So if we now update D1 with D2, let's see what happens. is, let's print D1, and there you go. The dollar sign, the dollar key has now the value of ampersand. Let's just quickly look at another function that is present inside the dict module, which is the values function. As you can guess, it returns all the values. Okay, so say D1, we have all these and all these key value pairs, and if I call the values function, it will return all the values inside a list, right? Okay, okay, and let's now look at the keys function. So you can guess it's quite intuitive. So the keys function will return you all the keys that are stored inside the dict. So d1.keys, sorry about that, d1.keys would return you all the keys that are stored inside the dictionary. Alright, let's now quickly look at the PopItem function from the dictionary module. What the PopItem function does is basically it removes the mentioned key and returns its values. So it's quite intuitive. You have gone over this in the set and lists. So let's just look at it. So D1 PopItem, and if I mention the dollar key over here, let's see what happens. Well, PopItem takes no arguments. So if you want to do something like this, you need to do pop. So there you go. So that would return the value that the key stores inside that dictionary and remove that key value pair from the dictionary. So you can see that the key value pair dollar and ampersand is not present inside the dictionary. So what does the PopItem function does then? The PopItem function, what it does, it basically returns, or sorry, removes an arbitrary element, or you can say an arbitrary key value pair that is stored inside the dictionary. So if you call pop on PopItem, the PopItem function on D2, which is a list we created earlier. So if I call PopItem on D2, it will remove an arbitrary element from the list. Sorry, from the dictionary. Okay, let's now move on to tuples. So what are tuples? Tuples are basically like lists. So you can think of tuples as lists, but they are immutable. That is, you cannot change tuples. That is, you cannot change the values stored inside the tuples, or you cannot add values to a tuple. Okay, let's now look at some examples, right? So tuples T1 equals to, you declare tuples with starting with the parenthesis, and let's add values 67, and let's have a character. Okay, so there you go, your tuple is created. Now if you want to run the length function to see the length of it, you can see the length of it, but what you cannot do is you cannot change the values that are stored inside the tuple. So if you want to do something like this, so let's just first access it. So you can access the elements inside the tuple like this. You can say the first element is, and they're all zero indexed. So you can also you can ask for the element that is sitting in the second position, which is the exclamation mark. But what you cannot do is you cannot change the element that are already sitting inside a created tuple. So if you want to do something like this, my friend, Python will not be very happy with you. He will throw errors and he will be very angry. Okay. Now, to change the tuple that is stored inside a variable, what you can do is you have to reassign a new tuple to that variable. So you cannot change the tuple that is stored inside T1. What you can do, you can reassign T1 to some a new tuple. Sorry about that. Oh, sorry. So you can reassign T1 to a new tuple. So TY 67. So T1 is now reassigned to a new tuple. Whoa, we have come a long way. So we learned about print statements, we learned about comments, we learned about the arithmetic operations, we learned about comparisons, we learned about sets, lists, dict, a lot of stuff. So we've come a long way, but we haven't looked at some of the basic operations yet which are used in Python, which are the conditional statements and the for loops and while loops in Python. So sit back and I'm going to just explain the simple concepts in no time. All right, let's now start with the conditional statements and then we'll move on to the loops. So to start with, what are conditional statements? Well, conditional statements are, we saw comparison operators, right? So conditional statements are that only, well, extended. You do some operations, you run some code when a certain condition is true. We write that if this condition is true, the Python should execute this part, then this block of code. Else, if this condition is true, Python should run this block of code. Else, if that condition is true, Python should run that block of code. Else, if none of the conditions are true, Python should run this block of code. Let's see it. Let's see an example. Okay, so you write if, and then you say the condition. You specify the condition which is going to be tested. So if say if 2 is greater than 3, then let's print yo. Okay. Sorry about that. Okay, so if 2 is greater than 3, let's print yo. And else, if it's not the case, that if 2 is not greater than 3, which is obviously 2 is not greater than 3, then let's print oy. Okay, and if you now execute it, you can see that the else part of the conditional statement gets executed since the condition 2 greater than 3 is false. Okay, so quite simple. Obviously this is extended, and let's now look at what are elif blocks. Okay, so if, elif, else. So what are elif blocks is basically they allow you to mention or allow you to state more conditions apart from if. So you start with if 2 greater than 3, then you print something, right? Elif 5 is greater than 6. So if you can see that I'm deliberately choosing these comparisons to be false, such that you can see what's going on exactly. So elif, I don't know, let's see, 56 is greater than 78. So you can have as many elif blocks as you want. And finally, when you are complete with the elif blocks, that you you will state the else block. You can state the else block, or else you cannot state the else block. It's completely up to the application that you're working on. Okay, that yeah. Okay, so not false again. Let's say true. Okay, now you can have the else block. So else, if none of these are true, then you run. Then you print, actually. You print popo. Okay. So you can see it prints popo because none of the conditions were true. Now what happens if some of the conditions were true? So let's see if let's see if 2 is less than 3. If 2 is less than 3, then let's print, okay, and elif. So just some examples here. Sorry, elif 5. Sorry, f5 and greater than 8. Then let's have something else. And you cannot it's as I said that else block are not a compulsory. You can have them if you wish. You cannot, you can omit them if you want, right? So as you can see, since 2 less than 3, the condition 2 less than 3 was true, HJ is printed, and elif 5 greater than 8 is not even checked, by the way. So if you have something like this, 2 less than 3, then print something, and if elif is also true, that is 4 is greater than 1, then you have to understand this part of the block is not even checked. So 2 less than 3, okay, that's true. Let's just execute whatever is inside the if block, and the elif blocks are not the preceding elif blocks and else blocks are not even checked. A key thing to notice here is the indentations that we are maintaining. The indentations are a must in Python. So here we have the if block, and then whatever block of code is under it or should be executed if that statement is true are indented at the right manner, right? So they're indented like 4 spaces, or you can have 8 spaces, but the indentation should be constant. Okay, so that you have to maintain. All right, let's now look at some one-liners. So what do I mean by one-liners? So one-liners is basically you run an if and else, not in 4 lines, but just in 1 line. Well, Python is famous for its one-liners, and all the whole lot of things you can do in Python just with a few lines of code. Okay, so let's just look at a few at an if-else one-liner. So say you want to say that you want to print yo-yo. Let's just leave it as oyo, and you want to print oyo if 2 is less than 3, else you want to print not oyo, or okay, not oyo. So there you go, oyo is printed, and if you just change this condition that 2 is greater than 3, not oyo is printed. So there you go, your first one-liner if else. Okay, let's now move on to for loops. So what for loops are is basically you write a block of code inside the for loop, and that block of code is executed again and again for a specific number of time. So let's just look at a for loop in action. So you write for I in range 2 to 5 and a colon, enter, and indentations are must, and then you say that, let's say print, okay, that is not a colon, yeah, there you go. So there you go, op whatever that is printed 3 times. Now let's look at the reason behind why that op is printed 3 times, or the reason that why that loop ran for 3 times. So we are new to this range function, right? So let's try to look at what this range function is. So if I list range 2 to 5, so we get 2, 3, 4, and that is exactly the reason why that loop ran for 3 times. Now if I change that loop 2 to 5 to print I, it stores each one of those values 2, 3, 4 for each run of the loop. Sorry, that's a syntax error. Sorry, print I, there you go. For each run of the loop, it stores that value. Okay, that is a basic for loop. Now you can also have something like this. So since range is like a list, as you already saw, you can convert range to list. So you can also have something like this, which is for I in a list 1, 2, Python 7 sorry, by 3.45, right? And then you can add the colon and do some operation to all these elements one at a time. Now you can also use the range function to skip a certain number of values. So let's see what I mean by that. So if we move back to 5, and if I say this is 20, and if I specify something like 2, then it skips 2 elements every time. So you can see 2, 4, 6, 8. On each iteration, it skips 2 elements. Okay. All right, that should give you a general idea of how for loops work. Now let's move on to while loops. So what are while loops? Well, they are loops again, but this time the conditions, or sorry, not the conditions, but the block of code that is inside the while loop is executed again and again and again until a certain condition is satisfied. All right, let's take an example of a while loop. So let's first declare a variable a, which is a value of 23, and let's then declare the while a is less than 30. We run a certain block of code which says print satisfied. So till the condition a less than 30 is satisfied, this block of code will keep running. Now what we need to do here is we need to increment a by 1. So what is that plus equal sign over there? That plus equal sign is equal to this. a equals to a plus 1. That is, in short, can be written as a plus equals 1. You can also write a plus equals 2, a plus equals 3. So let's look at this in action. So there you go. Satisfied printed 3 times. Why it's printed 3 times? Well, it starts at 23, and it prints satisfied, and at that iteration of the loop, the value of a gets incremented by 3, which is now 26, and then the second satisfied gets printed, and the value of a gets incremented to 29, and then the third satisfied gets printed, and then the value of a is greater than 30, the condition in the while statement goes false, so the condition is now unsatisfied, so the loop breaks out. Alright, let's now take a look at the most commonly used 2 statements in loops, which are the break and the continue statements. Now, what are the break statements? So inside a loop, while the loop is running, whenever a break statement is encountered, then the loop breaks out without executing whatever lines of code is after that break statement. And what a continue statement does is basically whenever a continue statement is encountered, that specific iteration is skipped. So the continue statement is encountered, all the lines of code that are preceding that continue statement are skipped completely, and a complete new iteration is started. And then again the condition is checked, and then the loop starts. But as I said, what the break statement does is whenever the break is encountered, all the preceding lines are skipped, obviously, and the loop breaks out completely. Okay, let's take an example of a break. So let's see what my a is right now. So a is 32. Now let's start a while, and let's say that while a is less than 40. So a is obviously less than 40. Let's print satisfied, and let's print enter. Now in this line, what's going to happen is I should increment a. If I don't increment a, then what I'm going to do is I'm going to start an infinite loop, because the value of a is always less than 40, and I am not increasing the value of a at all. So satisfied is going to be printed continuously infinite times, as the loop is not going to break. So let's just run this loop and let's see how it works out. So there you go. Satisfied is being printed again and again and again and again and again and again. And as you can see, my interpreter, the prompt inside the Python interpreter is not coming back. So to stop this, you want to hit Control C, and that's stopped. Okay, now moving on to the use of break statements. So if you remember, a is 32, and let's start with the while a equals 40, and then print satisfied, and this time let's use a break statement. So satisfied is going to be printed once, and then the break is going to be encountered, and Python is going to break out of that while loop. There you go. Satisfied printed once, and break is encountered, and we are breaking out of that while loop. And it works in a similar way for loop also. Alright, let's take a look at the continue statement. So similarly, let's say let's give this example about using for loops. So for I in a range 2 to 10, and let's see, if you remember, we skipped 2 values on each iteration with the extra 2 passing the extra 2 parameter to the range function. So let's do something different this time. Let's say if I mod 2 is equals 0, then we say continue. So each time I is divisible by 2, we continue. That is, we skip the rest of the lines that are inside this for loop, and we move on to a fresh new iteration. And inside this, let's say print I. So there you go, all the odd numbers printed. So each time the value of I is divisible by 2, we continue. All the preceding lines are skipped, and we move on to a fresh new iteration. And each time that if statement is not satisfied that continue is not executed, and therefore print is executed. Okay, let's now see how do you check if a value is present inside a list or a set or a tuple or something else, right? So how do you check if that value is present inside? So this is done using the in command. So let's say the value Python, okay, Python in a list, let's say the list contains Python itself, so that's going to return true. Is 56, 34, etc. So that's true. Now if that list is doesn't, if I remove Python from that list, then it's going to return false. And similarly we have one more, which is the not in, right? So that's going to return false. So it's quite intuitive. It's like you're reading a sentence, right? So Python not in that list, then you're going to return false, because that's the opposite. Because Python is in the list, it returns false. Okay, so that, and let's take a look at how do you convert a data type from to another. So let's say if you have something like 23, this 23 is of type int, right, of class int. And now if you say str, if you say str of a, then what's going to happen is type of a is going to become an str. So you change the type of a from int to str. Okay, similarly you can use int to change it back from str to int, right? So if you now run type of a, well, it's back to integers. All right, let's now look into errors and exceptions. And so what are exceptions? So exceptions are errors that are raised by Python during the usual execution of the code. Let's look at some examples of exceptions. So let's say that somehow we have our variable which is 0, and we don't know about it. So during the execution, during a lot of calculations that are going inside our code, somehow the variable a is now having 0, and there is another variable b which is having 23. Now say we are trying to divide this number b by a, but we don't know that a is now 0 because of some calculations that we did inside our code. So there you go, Python is now raising a 0 division error. So this is an example of an exception. So let's see one more example. So let's say we are trying to access a variable which is not yet defined. So let's see, let's try to access q, and there you go, that's another exception, the name error exception, as we are trying to access a variable that is not defined anywhere in the code. Okay, let's look at one more exception, which is the type error exception. Now what the type error exception is basically when you are trying to perform operations on data types that are not compatible, or let's see some examples that will be better. So let's say that you are trying to add 4.56 with this star. So there you go, type error. So you can possibly think that what the answer to that would be, right? So Python raises a type error which says that unsupported operand type plus for float and str, that it cannot sum up or cannot use the operand plus for the data types, that this which is one of which is in float and the other of which is in str. So similarly, if this would have been an str, Python would have easily done that. Okay, so what's the solution? During the execution of our code, we try to do something which can raise exceptions, and it's quite natural. So let's see, how do we handle exceptions? To handle exceptions, what we use are the try and except blocks. So what we do is we write try, and we say all the code that is prone to raise an exception are placed inside the try block. So let me just place b by a over here for now. So let's say c equals b by a. So if you remember, a is containing 0, so this is going to raise an exception called the zero division exception, right? So all the code which is prone to raise an exception is placed inside the try block, and then we have the except block, and inside the except block we can write, so we can look for this particular error, right? So zero division error, which is the error which we're looking for. So if zero division error is raised, so this except block just catches the zero division error. Okay, so this except block just catches the zero division error. So if in the try block we have some code which raises a name error or a type error, this except block will not catch those exceptions. So inside this except block, let me write print 0. Okay, so if you now read, so there you go. So 0 is printed as c is equals to b by a, rose an exception, and except zero division error caught that exception, and print 0 is executed. Okay, similarly you can have multiple except blocks which handles one exception at a time. So let me just show you some examples. Try, and then let's say I'm trying to access something which is not defined, a equals to q, and then I have except zero division error, and let's say print 0, and then we have except name error, right? So that's one. Okay, and then let's say print name. All right, so there you go. So this error except block is executed as the exception that is raised is the name error exception. So you can't possibly think of all the exceptions that are going to happen inside your try block, and you can't possibly go ahead and list all of them. So what's the usual thing to do is you can do something like this. So try, and then you have a equals q, and then you just write except, right? So it catches for all exceptions. So for all type of exceptions, if any exception is thrown, this except block will be executed. So you can have something like, so you can have a block of except zero division error, and then which follows a block of except name error, which follows some other blocks of some other exceptions which you want to handle separately, and then you can finally have an except block for all the other types of error that you want to handle, a common except block, right? And let's see in an action, right? So 0, and there you go. Okay, so the try except statement also has an optional else clause, which when present must follow all the except clauses. Okay, so what is contained in this else block is the code which needs to be executed if the try block doesn't raise any exception. Okay, so let's see it in action. Try a equals let's say for 34, so that won't raise any exception, except print exception, and then let's have an else. So, and over here let's print try executed. Okay, so there you go, try executed. So, and a now holds 34, by the way. So whenever the try block is executed successfully, then this else block will also be executed. Okay, so the use of else clause is better than adding additional code to the try clause because it avoids accidentally catching an exception that wasn't raised by the code being protected by the try and except statement. Okay, let's now take a quick look into the how can you define functions in Python. Functions in Python are defined using the def keyword followed by the function name, and then you can have your open and close parenthesis, and inside this parenthesis you can have all the arguments and parameters that should be passed inside the function, and then with the colon you hit enter, and then you can you have all your logic inside of the function written over here. So let me just quickly write something simple over here. So a equals 34, b equals 90, and c equals 56. Okay, now to return something from the function, you use the return statement, right? And over here you can have a plus b plus c. So a plus b plus c is now returned. Okay, so this function is now defined. Now let's just try and call this function. So func, there you go, 180 is returned. Okay, so that was simple. Let's just go ahead and take an example where we are passing a few parameters to the function, right? So def func, and let's say first parameter is a, second is b, and then you can have what are called default parameters. So c equals 3. So if the user needs to pass the parameter a and the parameter b, and then he or she may or may not pass c. If he or she passes c, then that value will be used for the value of the variable c, else the default parameter is 3. All right, so let's go ahead and see in action. So I'm just gonna return the addition of the 3, a, b, and c. Okay, now if I call func with 3, 5, and it's going to return 11. So the default value of c is 3 since I have not passed it. And if I now pass something, there we go. So the value of c is now 0 as I have passed something. So what you want to do is you cannot have default parameters before these normal parameters, right? So all the default parameters should be stuck to the right. Okay, so you cannot have normal parameters after defining default parameters. All right, now let's move on to the final topic in this video, which are files. So how to operate on files, that is how to open files, how to write to files, how to read from files using Python. Okay, let's now see how you open a file in Python. So fopen equals, and you can use the open option, and then you can have your path name. So over here, as the first argument, you pass the path to which the file is present. So you can have an absolute path or relative path. If you don't know what's the difference between an absolute path or a relative path, you can search them up on the internet. So I'm just gonna type the name of the file as tr.txt, and this means that the tr.txt file is present in my current directory. And then we are on to the next argument, which can have 4 different values. Now what are these 4 different values and what does they mean? So let's just list the 4 different values, and then let's go over what they mean one at a time. So r, w, a, and r plus. So what does this means? R over here means that it opens the file tr.txt in read-only mode. W means that it opens the file tr.txt in write-only mode. Append means that it opens the file to append information to the file and retains whatever information is already present. And R plus means that it opens the file to read as well as write. All right, so one thing you have to remember is if you're opening the file in R, that is read-only mode, you have to make sure that the file tr.txt or whatever the name of your file is exists in the given path. So you can see that if you say that you want to open the file in read-only mode, and actually I don't have tr.txt called file inside my current working directory, so Python throws an error called the file not found error, because the file is not present in my current working directory. Similarly, if you open the file with W, that is write mode, whatever information is present inside the file are all erased. Okay, you lost all the information. And and obviously if the file tr.txt is not present in your current working directory, Python will create the file for you. So if I now hit enter, Python creates the file for me, and now I can write to the file. Okay, append, as I said, retains all the stored information inside the file, and when you open the file you can append new information to it. And R plus, well, I said that it allows you to read and write. Okay, let's now write to this file, and let's see how can we write to this file, and then we'll read from this file. Okay, so let's just start by writing. So to write to this file, we say that fopen.write write, and then whatever you want to write. So la 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 la. Okay, you press enter, and everything is just, so the 16 just mentions the length of the characters that are written to this file. Okay, so you can continue writing, and you can say you can write anything you want, right? So you can keep on writing as and how required. You can have your new line characters over here. So if you say new line, a new line is appended at the end. So if you don't say new line, no new lines are appended. So this DH, whatever this is followed by FJ without any new lines. Okay, all right. Now, so you have wrote to the file, and you can now use the close option to close the open file, and this file is now in your current working directory with this garbage information right over here. Okay, so the file is now closed. You have wrote to this file. Now let's reopen this file in read mode, and let's read from this file. So let's see, fopen, and you're gonna mention the file name, and let's now read from this file. Now let's see. Now remember, previous time when we ran this, we ran into an error because this file doesn't exist at that time. Didn't exist at that time, right? But this time, this file exists, my friend. We have done a good job. Let's now press enter and get the file. All right, the file's with us, man. So how do you read? Okay, to read, all you have to do is you can say contents, and you can say fopen dot read. So all the values that are inside the file are now stored in contents. So you can now print contents, and there you go. All the values are now there. So you read the contents of the file, and let's now close this file. So always remember to close your file when you're done with all the operations that you need to perform with the file. With that, let's see a very clear way to read files. So it is done with the with command. Okay, so with open, and you're gonna mention your file name ter.text, with open ter.text as fopen. I'm gonna use the same variables so you can keep a track of what's going on, and fopen, and then contents is equals to fopen dot read. Okay, and there you go. In this case, you don't need to use the fopen.close function. With does that job for you. It with keeps the file open as long as it's needed and then closes it. So, and in your contents is that information that is read from the file. All right, we are at the end of Python Boost tutorial. I hope I've been able to help you all get Boost started with Python. If so, if you like the video, do leave a like below and do share it with your friends. Okay, and all right, let's say bye-bye, and as it says here, let's say sayonara, and always remember, Python rocks. All right, bye-bye.